Good day to everyone. My name is Alrich Dale Hilera, and our group will be presenting about Chapter 7, which is Interfaces. But before we discuss this chapter, let us first know what are the objectives of this topic. The main goals of this chapter are to accomplish the following. Number 1. Provide an overview of the many different kinds of interfaces. Number 2. Highlight the main design of research considerations for each the interfaces. Number 3. Disclaim what is meant by a natural user interface or NUI. And lastly, consider which interface is best for a given applications or activity. Now, what is interface? An interface is a set of dial, knobs, operating system commands, graphical display formats, and other devices provided by a computer to allow the user to communicate and use the computer or a program. So the interface allows the user and the computer to communicate with the help or use of each respective commands and graphical display formats, which is or provided by the computer or any devices itself. In computing, an interface is a shared boundary across which two or more separate components of a computer system exchange information. The exchange can be between software, computer hardware, peripheral devices, humans, and combinations of these. These interactions between your system and others are what we call interfaces. Identifying interfaces helps you to define your system boundaries. It also helps you to understand the dependencies your system has with other systems and dependencies other systems have with your system. So basically, interfaces does not allows help you to define your system boundaries, and it also gives you information on what are the boundaries of the other systems are. The types of interfaces that we will discuss will start from command interface, graphical interface, multimedia interface, virtual reality interface, so on, and up till the smart interfaces. Firstly, we will discuss about the command interface. Command interface enables the user to type commands in a console window to interact with an operating system using detailed commands through a command line interface. Can be faster and more efficient than scrolling across GUI or graphical user interface tabs and dialogues. These can be more powerful when handling highly repetitive tasks across many systems. So the command interface enables the user to type commands with the use of keyboard to interact with its operating system. Just like I said, this can be more powerful when handling highly repetitive tasks across many systems, because command line interface has a set or his own commands. The MS-DOS operating system and the command shell in the Windows operating system are examples of command line interfaces. In addition, Programming language development platforms such as Python can support command line interfaces. Just like in Python, you can use command line interfaces simply just by tapping or inputting the right command to execute or run your programs and system. There are many different types of command line interfaces, but the two most popular ones are DOS for Windows and the Bash shell for Linux and OS X. Each command line interfaces uses its own command syntax, but they all function in a similar way. And just like as I said earlier for Python, each operating system has its own command line interface which uses their own command syntax, uh, and even if they have their own syntax, they still all function or run in a similar way. And the next interface that I will be discussing is the graphical interface. Graphical interface enables the user to interact with electronic devices such as computers and smartphones through the use of icons, menus, and other visual indicators. Graphical user interface would become the standard of user-centered design in software application in programming. So, GUI can become the standard of user-centered design in software application because it can be much more easy to use since you can just interact with your electronic devices through the use of the icons, menus, and other visual indicators. Creating a graphic user interface allows the user to interact directly with their devices and complete certain tasks by manipulating elements such as icons, scroll bars, to make their digital devices more efficient and usable. Graphical user interface examples includes computer monitors, smartphones, tablet, or other consoles that checks the screen to find the location and movement of the pointing devices on the screen. So, GUI or graphical user interface allows the user to find or search for a specific icons or file that he's trying to find just by pressing the icon, like photos and others, unlike by typing in their computer to find their specific file that they are looking for. Now, multimedia interface. Multimedia interface are capable of transmitting uncompressed audio or visual data. It is also devices that can interact with multiple senses are called multimedia user interfaces. For example, everyday user interface uses a combination of tactile input and a visual and auditory output. So, interactive multimedia allows the user to control, combine, and manipulate a variety of media types, such as text, computer graphics, audio and video materials, as well as animation. Interactive multimedia integrates computer, storage, data, phone, television, and other information technologies. So in multimedia interface, any devices just like computers, smartphones, tablets, or even televisions, as long as Uh, it allows the user and the device to interact. We can consider this as a multimedia interfaces. And now, uh, virtual reality interfaces. With virtual reality interface, the user is connected to the system as a part of an input or output loop, allowing the individuals to provide inputs to the virtual environment and experiment as a result of that input. Virtual reality, or also known as VR, is a new and cutting edge technology that has crossed the barriers to enter into different industry verticals, simulating a physical presence in the real and imaginary world is one of the major aspects of virtual reality. Since in technology, virtual reality is now popular in the people since it has crossed the barriers, industry verticals, in which you can enter the imaginary world through the use of a specific virtual reality devices. Virtual reality interface devices such as the Nintendo Wii and its peripheral nunchucks balance board, head-mounted displays, and joysticks allows interaction and immersion in unreal environments created from computer software. Just like I said earlier, in the virtual reality devices that are popular nowadays, just like Nintendo Wii, you can use its device to play physically and enter the imaginary world or imaginary environment from the computer software that develops by the producer itself. Not by only playing. You can also use VR into socializing with other people from the other parts of the world. You can use it by entering into a specific server or a specific world that allows the people to interact with others even if they are physically bound into their own places. And now, let us hear from my groupmate, Mr. Vito.
Thanks, Mr. Herrera. Hello, my name is Bernardo D. Vitug, and I am here to talk about four other interfaces. First, let's start with web design. Early websites were largely text-based, providing hyperlinks to different places or pages of text. Much of the design effort was concerned with the information architecture, that is, how best to structure information at the interface level to enable users to navigate and access it easily and quickly. The goal of web design has been to develop sites that are not only usable but also aesthetically pleasing. Getting the graphical design right, therefore, is critical. The use of graphical elements such as background images, color, bold text, and icons can make a website look more distinctive, striking, and pleasurable for the user when they first view it, and also to make it readily recognizable on their return. Steve Krug argues that web designers create sites as if the users were going to pore over pages, reading the finely crafted text word for word. Users, however, will glance at a new page, scan part of it, and click the first link that catches their interest. To help navigate their way through the many choices that web developers have to make, Jason Bird and James George have come up with a number of guidelines intended to help web developers achieve a balance between using color, layout, and composition, texture, typography, and imagery. They also cover mobile and responsive web design. Other website guidelines are mentioned in Chapter 16. Next, we have mobile. Mobile devices have become pervasive, with people increasingly using them in all aspects of their everyday and working lives, including phones, fitness trackers, and watches. Customized mobile devices are also used by people in diversity of work settings, where they need to access real-time data or information while walking around. Larger size tablets are also used in mobile settings. For example, many airlines provide their flight attendants with one so that they can use their customized flight apps while airborne and at airports. Sales and marketing professionals also use them to demonstrate their products or to collect public opinions. Smartphones and smartwatches have an assortment of sensors embedded in them, such as an accelerometer to detect movement, a thermometer to measure the temperature, and galvanic skin response to measure changes in sweat levels on one's skin. Other apps may be designed for fun. Smartphones can also be used to download contextual information by scanning barcodes in the physical world. Another method that provides quick access to relevant information is the use of quick response or QR codes that stores that store URLs and look like black and white checkered squares. They work by people taking a picture using their camera phone that then takes them to a particular website. Moving on, we have appliance. Appliances include machines for everyday use in the home. For example, washing machines, microwave ovens, refrigerators, toasters, bread makers, and smoothie makers. What they have in common is that most people using them will be trying to get something specific done on a short period of time, such as starting a wash, watching a program, buying a ticket, or making a drink. They are unlikely to be interested in spending time exploring the interface or looking through a manual to see how to use the appliance. Many of them now have LED displays that provide multiple functions and feedback about a process, such as being able to see the temperature, minutes remaining, and so on. Some have even begun to be connected to the internet with companion devices, enabling them to be controlled by remote apps. An example is a coffee maker that can be controlled to start at a certain time from an app running on a smartphone or controlled by voice. Lastly, we have voice. A voice user interface, or VUI, involves a person talking with a spoken language app, such as a search engine, a train timetable, a travel planner, or a phone service. It is commonly used for inquiring about specific information, for instance, flight times or weather, or issuing a command to a machine, such as asking a smart TV to select an action movie or asking a speaker to play some upbeat music. VUIs is use an interaction type of command or conversation where users speak and listen to an interface rather than click on, touch, or point to it. Sometimes the interaction style can involve the user responding where the system is proactive and initiate the conversation. For example, asking the user if they would like to stop watching a movie or listen to the latest breaking news. The first generation of speech systems earned a reputation for mishearing all too often what a person said. However, they are now much more sophisticated and having higher levels of recognition accuracy. Machine learning algorithms have been developed that are continuing to improve their ability to recognize what someone is saying. BUIs have become popular for a range of apps. Speech-to-text systems such as Dragon enable people to dictate rather than have to type. Whether it is entering data into a spreadsheet, using a search engine, or writing a document, the words spoken appear on the screen. One of the most popular applications of speech technology is call routing, where companies use an automated speech system to enable users to reach one of their servers during a phone call. Callers voice their needs in their own words. For example, I'm having trouble with my Wi-Fi router, and in response are automatically forwarded to the appropriate service. That's all from me. Now, for the next reporter, we have Mr. Cabrera.
Good afternoon, everyone. I'm Jude Michael A. Cabrera, one of the reporters of Group 7. So, pen-based devices enable people to write, draw, select, and more objects on an interface using light pens or styluses that capitalize on the well-honed drawing and writing skills that are developed from childhood. So, they have been used to interact with tablets or cell phone and large displays instead of using mouse touch or keyboard input for selecting items and supporting freehand sketching. This can be useful for applications that require people to fill in the paper, base forms, and also for taking notes during meetings. So another advantage of digital pens is that they allow users to annotate existing documents such as spreadsheets, presentations, and diagrams quickly and easily. This is useful for a team who is working together and communicating to each other from different locations. One problem with using pen-based interaction on small screens, however, is that sometimes it can be difficult to see options on the screen because a user's hand can obscure part of it when writing. So the next one is touchscreens. So single touchscreens used in walk-up kiosks also are using cell phone, such as ticket machines or museum guides. ATMs and cash registers had been around for a while. They work by detecting the presence and location of a person's touch on the display. Options are selected by tapping on the screen. Multi-touch surfaces, on the other hand, support a much wider range of more dynamic fingertip actions such as swiping, flicking, pinching, pushing, and tapping. They do this by registering touches at multiple locations using a grid. So this multi-touch method enables devices such as smartphones and tabletops to recognize and respond to more than one touch at the same time. So the next one is gesture. So gestures involve moving arms and hands to communicate. For instance, waving to say goodbye or raising an arm to speak in class or to provide information to someone. For example, holding two hands apart to show the size of something. So there has been much interest in how technology can be used to capture and recognize a user's gesture for input by tracking them. So using cameras and then analyzing them using machine learning algorithms.
Greetings everyone. I'm Renz Talents and I'm going to discuss haptics, multimodal and shareable interfaces. Haptic interfaces. Haptic is the science and technology of transmitting and understanding information through the sense of touch. Haptic interfaces provide tactile feedback by applying vibration and force to the person, using actuators that are embedded in their clothing or a device that they are carrying, such as smartphone or smartwatch. Haptic interfaces provide tactile feedback by applying vibration and force to the person, using actuators that embedded in their clothing and device, and it was commonly used in game. For example, If you are familiar with the game Guitar Hero, the controller will vibrate to indicate if you miss a single note. Multimodal interface. Multimodal interface processes two or more combined user input modes, such as speech, pen, touch, manual gesture, and gaze in a coordinate manner with multimedia system output. Multimodal support more flexible, efficient, and expressive means of human-computer interaction. Example of multimodal interfaces is a Microsoft Xbox Kinetic. It was developed as a gesture and body movement gaming input system for the Xbox. It can be used to perform a real-time gesture recognition and body skeletal detection, among other capabilities. It also contains microphones that can be used for speech recognition and voice control. Wearable interfaces are designed for more than one person to use. Unlike PC, laptop, and mobile devices which are aimed at single user, shareable interfaces typically provide multiple inputs and somehow allow simultaneous input by located groups. These include large walls display, for example smartboards, where people use their own pens or gestures, and interactive tabletops, where small groups can interact with information being displayed on the surface using their fingertips.
Hello, my name is Steven Fincalero and I will report about tangible interfaces, augmented reality, and wearables. Tangible interfaces use sensor-based interaction where physical objects such as bricks, balls, and cubes are coupled with digital representation. When a person manipulates the physical objects, it is detected by a computer system via the sensing mechanism embedded in the physical object, causing a digital effect to occur, such as a sound, animation, or vibration. The digital effects can take place in a number of media and places, or they can be embedded in the physical object itself. For example, Oren Zuckerman and Mitchell Resnick's early flow block prototype depicted changing numbers and lights that were embedded in the blocks, depending on how they were connected. The flow blocks were designed to simulate real-life dynamic behavior and react when arranged in certain sequences. Another type of tangible interface is where a physical model, for example, a puck, a piece of clay, or a model, is superimposed on a digital desktop. Moving one of the pieces around the tabletop causes digital events to take place on the tabletop. One of the earliest tangible interfaces, ERP, was built to facilitate urban planning. Miniature physical models of buildings could be moved around on the tabletop and used in combination with tokens for wind and shadow generating tools, causing digital shadows surrounding them to change over time and visualization of airflow to vary. Tangible interfaces differ from other approaches such as mobile insofar as the representation are artifacts in their own right that the user can directly act upon, lift up, rearrange, sort, and manipulate. The technologies that have been used to create tangible include RFID tags and sensor embedded in the physical object and digital tabletops that sense the movement of objects and subsequently provide visualization surrounding the physical objects. Many tangible systems have been built with the goal of encouraging learning, design activities, playfulness, and collaboration. These include planning tools for landscape and urban planning. Another example is Tinkersheets, which combine tangible models of shelving with paper forms for exploring and solving warehouse logistic problems. The underlying simulation allows students to set parameters by placing small magnets on the form. Tangible computing has been described as having no single locus of control or interaction. Instead of just one input device, such as a mouse, there is a coordinate interplay of different devices and objects. There is also no enforced sequencing of actions and no model interaction. Moreover, the design of the interface objects exploits their affordance to guide the user in how to interact with them. A benefit of tangibility is that physical objects and digital representation can be positioned, combined, and explored in creative ways, enabling dynamic information to be presented in different ways. Physical objects can also be held in both hands and combined and manipulated in ways not possible using other interfaces. This allows for more than one person to explore the interface together and for objects to be placed on top of each other, beside each other, and inside each other. The different configurations encourage different ways of representing exploring a problem space. In so doing, people are able to see and understand situations differently, which can lead to greater insight, learning, and problem solving than with other kind of interfaces. A number of toolkits have been developed to encourage children to learn coding, electronics, and STEM subjects. These include Little Bits, Microbit, and Magic Cubes.
The toolkits provide children with opportunities to connect physical electronic components and sensors to make digital events occur. For example, the magic cubes can be programmed to change color depending on the speed at which they are shaken. Slow is blue and very fast is multicolor. Research has shown that the tangible toolkits provide many opportunities for discovery learning, exploration, and collaboration. The cubes have been found to encourage a diversity of children between the ages of 6 and 16, and those with cognitive disabilities, to learn through collaborating, frequently showing and telling each other and their instructors about their discoveries. These moments are facilitated by the cube's form factor, making it easy to show off to others. For example, by waving a cube in the air, tangible toolkits have been developed for the visually impaired. For example, Torino, written by Microsoft to Code Jumper, was developed as a programming language for teaching programming concepts to children aged 7 to 11. Regardless of level of vision, it consists of a set of bits that can be connected and manipulated to create physical strings of code that plays, stores, or music. Voxbox is a traditional method for gathering public opinion, such as surveys, involve approaching people in situ, but it can disrupt the positive experience they are having. Voxbox is a tangible system designed to gather opinions on a range of topics in situ at an event through playful and engaging interaction. It is intended to encourage wider participation by grouping similar questions, encouraging completion, gathering answers to open and closed questions, and connecting answers and results. It was designed as a large physical system that provides a range of tangible input mechanism through which people give their opinions, instead of using, for example, text messages or social media input. The various input mechanisms include sliders, buttons, knobs, and spinners about which people are all familiar. In addition, the system has a transparent tube at the side that wraps a ball step by step as sets of questions are completed to act as an incentive for completion and as a progress indicator. The results of the selection are aggregated and presented as simple digital visualization on the other side. Voxbox has been used at a number of events, drawing in the crowds, who became completely absorbed in answering questions in a tangible format. Augmented reality, or AR, became an overnight success with the arrival of Pokemon Go in 2016. The smartphone app became an instant hit worldwide. Using a player's smartphone camera and GPS signal, the AR game makes it seem as if virtual Pokemon characters are appearing in the real world, popping up all over the place, such as on buildings, on streets, and in parks. As players walk around a given place, they may be greeted with rustling bits of grass that signal a Pokemon nearby. If they walk closer, a Pokemon may pop up on their smartphone screen as if by magic and look as if they are actually in front of them. For example, one might be spotted sitting on a branch of tree or a garden fences. AR works by superimposing digital elements, like Pokemons, onto physical devices and objects. Closely related to AR is the concept of mixed reality, where views of the real world are combined with views of virtual environment. To begin, augmented reality was mostly a subject of experimentation within medicine, where virtual objects, for example X-rays and scans, were overlaid on part of patient's body to aid the physician's understanding of what was being examined or operated on. AR was then used to aid controllers and operators in rapid decision making. One example is air traffic control, where controllers are provided with dynamic information about the aircraft intersection that is overlaid on a video screen showing real planes landing, taking off, and taxiing. The additional information enables the controllers to identify planes easily, which were difficult to make out, something especially useful in poor weather conditions. Similarly, head-up displays HUDs are used in military and civil planes to aid pilots when landing during poor weather conditions. A HUD provides electronic directional markers on a fold-down display that appears directly in the field of view of the pilot. A number of NCARs now provide AR windshield technology, where navigation's direction can literally look like they are painted on the road ahead of the driver. Instructions for building or repairing complex equipment such as photocopiers and car engines have also been designed to replace paper-based manuals, where drawings are superimposed upon the machinery itself, telling the mechanic what to do and where to do it. There are also many AR apps available now for a range of contexts, from education to car navigation, where digital content is overlaid on geographic locations and objects. To reveal the digital information, users open the AR app on a smartphone or tablet and the content appears superimposed on what is viewed through the screen. Other AR apps have been developed to aid people walking in a city or town. Directions in form of a pointing hand or arrow, and local information. For instance, the nearest bakery, are overlaid on the image of the street ahead that appears on someone's smartphone screen. This changes as the person walks up the street. Virtual objects and information are also being combined to make more complex augmented realities. The picture shows a weather alert with animated virtual lightning effect alongside information about a nearby cafe and the price of properties for sale or rent on the street. Holograms of people and other objects are also being introduced into AR environments that can appear to move and or talk. For example, visual tour guides are beginning to appear in museums, cities, and theme parks, which can appear to be by moving, talking, or gesturing to visitors who are using an AR app. The availability of mapping platforms such as those provided by Niantic and Google, together with Apple's AR Kit, Spark AR Studio, and Google's AR Core, has made it easier for developers and students alike to develop new kinds of AR games and AR apps. Another popular AR game that has emerged since Pokemon Go is Jurassic World Alive, where players walk around in a real world to find as many virtual dinosaurs as they can. It is similar to Pokemon Go but with different gaming mechanism. For example, players have to study the dinosaurs they came across by collecting their DNA and then recreating it. Microsoft's HoloLens toolkit has also enabled new mixed reality user experiences to be created, allowing users to create or interact with virtual elements in their surroundings. Most AR apps use the backward-facing camera on a smartphone or tablet to overlay the virtual content onto the real world. Another approach is to use the forward-facing camera to superimpose digital content onto the user's face or body. The most popular app that does use this technique is Snapchat, which provides numerous filters with which people can experiment, plus the opportunity to create their own filters, adding accessories such as ears, hair, moving lips, and headgear, enabling people to transform their physical appearance in all sorts of fun ways. This kind of virtual try-ons work by analyzing the user's facial features and building a 2D or 3D model in real time. So when they move their head, the makeup or accessories appear to move with them as if they are really on their face. Several AR mirrors now exist in retail that allow shoppers to try on sunglasses, jewelry, and makeup. The goal is to let them try on as many different products as they like to see how they look with them on. Clearly, there are advantages to virtual try-ons. It can be more convenient, engaging, and easier compared to trying on the real thing. There are disadvantages too. However, in that they only give an impression what you look like. For example, the user cannot feel the weight of a virtual accessory on their head or the texture of virtual makeup on their face. Wearables are a broad category of devices that are worn on the body. These include smartwatches, fitness trackers, fashion tech, and smart glasses. Since the early experimental days of wearable computing, where Steve Mann donned head and eye cameras to enable him to record what he saw while also accessing digital information on the move. There have been many innovations and inventions including Google Glass. New flexible display technologies, e-textiles, and physical computing, for example Arduino, provide opportunities to design wearables that people will actually want to wear. Jewelry, caps, glasses, shoes, and jackets have all been the subject of experimentation designed to provide the user with the means of interacting with digital information while on the move in the physical world. Early wearables focus on convenience, enabling people to carry out a task, for example, selecting music, without having to take out and control a handheld device. Examples included a ski jacket with integrated music player controls that enable the wearer to simply touch a button on their arm with their glove to change a music track. More recent applications have focused on how to combine textiles, electronics, and haptic technologies to promote new forms of communication. For example, Cute Circuit developed the kinetic dress, which was embedded with sensors that followed the body of the wearer to capture their movements and interaction with others. These were then displayed through electroluminescent embroidery that covered the external skirt section of the dress. Depending on the amount and speed of the wearer's movement, it changed patterns, displaying wearer's mood to the audience and creating a magic halo around her. Exoskeleton clothing is also an area where fashion meets technology in order to augment and assist people who have problems with walking by literally walking or exercising the person wearing them. In this way, it combines haptics with a wearable within the construction industry. Exoskeleton suits have also been developed to provide additional power to workers, a bit like Superman, where metal frameworks are fitted with motorized muscles to multiply the wearer's strength. It can make lifting objects feel lighter and in doing so protect the worker from physical injuries. Google Glass was a wearable that went on sale in 2014 in various fashion style. It was designed to look like a pair of glasses, but with one lens of the glass being an interactive display with an embedded camera that could be controlled with speech input. It allowed the wearer to take photos and videos on the move and look at digital content, such as email, text, and maps. The wearer could also search the web using voice commands, and the result would appear on the screen. A number of applications were developed beyond those for everyday use, including Watch Me Talk, which provided live action to help the hearing impaired in their day-to-day conversations, and Preview for Glass that enabled the wearer to watch a movie trailer the moment they looked at a movie poster. However, being in the company of someone wearing a Google Glass was felt by many to be unnerving, as the wearer looked up into the right to view that what was on the glass screen rather than looking at you and into your eyes. One of the criticisms of wearers of Google Glass was that it made them appear to be staring into the distance. Others were worried that those wearing Google Glass were recording everything that was happening in front of them. As a reaction, a few bars and restaurants in the United States implemented a no glass policy to prevent customers from recording other patrons. The original Google Glass was retired from couple of years. Since then, other type of smart glasses have onto the market that sync a user's smartphone with the display and camera on the glasses via Bluetooth. These include Music Blade, which has a camera on board and voice control that is connected to Amazon Echo devices, along with the provision of turn-by-turn navigation and location-based alerts, and Snap Spectacles, which simply allows the wearer to share photos and video with their friends on Snapchat they take when wearing these glasses.
My name is Katusha F. Toilo, and my report is about robots and drones interface, brain-computer interface, and smart interfaces. A machine designed to carry out a certain task automatically with speed and precision. It has a sense and react to the environment, guided by a computer program and electric circuitry. Robots have been around for some time. A robot is a machine that can be automatically complete a complex series of tasks, especially one that can be programmed by a computer. Robots can be controlled internally or externally by means of a control mechanism. Although some robots are built to resemble humans, most robots are task-performing machines that place a greater emphasis on bare functionality than on expressive aesthetics. We have here is an example of a robot. Japanese inventor Takanori Shibata developed Paro in 2004, an interactive seal and whose role was a companion. Sensors were embedded in the pet robots, enabling them to detect certain human behaviors and respond accordingly. Drones, unmanned aerial vehicle or UAV, an aircraft without a human pilot aboard. It is a flying robot, either remotely controlled or can fly autonomously. Drones is a console interfaces that have been developed to enable humans to control and navigate robots in remote terrains, using a combination of joysticks and keyboard controls together with camera and sensor-based interactions. The focus has been on designing interfaces that enable users to steer and move a remote robot effectively with the aid of live video and dynamic maps. Drones are used for a variety of tasks now, including tracking climate change, conducting searches after natural disasters, taking pictures and videos, and delivering goods. Although the military uses them most for special operations, surveillance, and targeted attacks. Brain-computer interface. A brain-machine interface, also known as a brain-computer interface, is a direct line of communication between the electrical activity of the brain and an outside device, most frequently a computer or robotic limb. BCIs are frequently used to study, map, support, improve, or restore human cognitive or sensory motor functions. Several research projects have investigated how this technique can be used to augment and support human cognitive or sensory motor functions. BCIs function by spotting changes in the way the brain's neural pathway function. The neurons that make up each individual nerve cell in our brains are connected to one another by dendrites and axons. These neurons become active whenever we think, feel, act, or remember something. Electrodes positioned on a person's scalp can, to some extent, detect the small electric signals that are rapidly moving from neurons to neurons. Specialized headset, hairnets, or cups contain electrodes inside of them. Smart interfaces. Making things smart is the driving force behind many new technologies. Whether it's a smartphone, smartwatch, smart building, smart home, or smart appliance. For example, smart lighting, smart speakers, or virtual assistants. In a simple terms, smart devices are made to communicate with people and other network devices. Many of these interactions are automated and do not require direct user interactions. The goal is to make them context aware. In order for them to be aware of their surroundings and able to take the proper action, for this to happen, some have given AI or artificial intelligence programming that enables them to understand the environment and the action of a user. With the help of this intelligence, they then enhance the settings or turn on devices in accordance with the user's presumptive preferences. Smart buildings have been created to be more energy efficient, and cost efficient. Modern sensor technology is being used by architects to manage building systems like ventilation, lighting, security, and heating. This purpose requires to take into account the needs of the people along with the introduction of smart technology. For instance, the term human building interaction or HBI refers to a new approach that puts resident at the center. It aims to comprehend and influence how people interact with and use built environments. Human values, needs, and priorities are the main considerations when addressing how people interact with smart environments. That's all for our report on Chapter 7 Interfaces. Thank you.